What do you mean by real number? Any number that can be represented on number line is called real number. Is called a real number. Means before this, you know how to represent natural number on number line. And draw the number line. 0, right hand side.
Natural number, whole
Whole
number,
number, integers, rational number. Till this, you know how to represent this number on number line. And also you know how to represent irrational number also on number line. In 9th class, first chapter, you know how to represent root 2 on number line, root 3 on number line, root 5 on number line, root 6 on number line. Okay? That means if I write the number hierarchy or number diagram, number is divided into two categories. Real number, real,
real number,
real number,
unreal number, rational, irrational number.
no, real number and a imaginary number. Real number and a
Imaginary number.
imaginary, imaginary number or a complex number or a
Complex.
complex number. Remember, this chapter you will learn on 11th class. Okay.
Okay.
First to focus, what do you mean by imaginary number? Only small description. Okay, tell me, what is the square root of 4?
2.
2. That means can I write 4 as 2 into 2 and this is the value. Same, I can write minus 2 into minus 2 also. But the question is, if I am asking what is the square root of a minus 1? Means some minus number inside root. This is called imaginary number, because you don't know which two type of a number you multiply to get this number. Okay? This is called imaginary number. Leave the imaginary number concept. Number, real and imaginary. Imaginary number means only example minus 1. Any minus number root over. Real number are two types, rational and irrational. Rational and irrational. Rational are the rational are p by q, otherwise you can say natural number, whole number, then integer, then fraction, then terminating decimal, and non-terminating recurring decimal. क्योंकि non-terminating are of two types. Non-terminating recurring means like 1.1111. It is non-terminating, but recurring means repetitive 1.1 bar. I can write it as terminating means 1.2. I can write 1.2 as 12 by 10, na? And you know how to convert this 1.1 bar into fraction. It is the 9th class concept. Leave this. Okay. And natural number are divided into two parts: real number and imaginary number. Real number are of two types: real and irrational. Rational and irrational. Rational means any number that can be written in form of a p by q, where pq must be integer, q does not equal to 0. The example are natural number, whole number, integer, fraction, terminating decimal, non-terminating repeating decimal. Irrational number, direct one thing you remember: square root of n, where n is not a perfect square. Where n is not a perfect square. What does it mean?
Non-terminating, non-repeating भी इसी में आता है.
Only three things you have to remember for knowing whether the given number is irrational or not. You can apply the p upon q wala form. Irrational means it is opposite to the rational. Irrational means any number that cannot be written in form of p by q, where q does not equal to 0, pq must be integer. Cannot be. Okay, it is exactly opposite. Like 3 upon 0. 3 upon 0. It is irrational number, na? Because here q does not equal to 0. Q equal to 0. Except this, you have to remember these three examples. What are the three examples? Square root of n, where n is not a perfect square. N is not a perfect square. Perfect square. What do you mean by perfect square? 1 square equal to 1. 2 square equal to 4. 3 square equal to 9. In between the number. Root 2, root 3, root 5, root 6. Remember, if you root over 16, yes, I can able to remove the square root 4. So it is not a irrational number. Okay, you remember this thing? Example, how you identify whether the given things is irrational or not? Only n is not a perfect square. नहीं होगा. Then the next thing, by you can say square root of a prime number. Square root of a prime number. Or if you say 6 is not a prime, but you know I can convert it into 2 into 3, na? Anything 3, 5, or directly remember non-terminating, non-recurring decimal. This is the example of also irrational number. 1.11325498 This is called non-terminating, non-recurring. Non-terminating means the decimal expansion is going on and there will be no particular order of a number. Okay, you understand the hierarchy? Number, real number, imaginary number. Real number are of two types: rational number, irrational number. Okay, and how to identify rational number, how to identify irrational number. Then the concept is, what do you mean by number? Only for small recap, I'm telling you, number is a mathematical concept. Number is a mathematical concept that is used for counting, measuring, and leveling. Number is nothing but a mathematical concept that is used for counting, measuring, and leveling. Counting. Example for counting. Tell me how many circles are there? 4. So here you are using number for counting, na? Tell me what is the length of this rectangle? 5 centimeter. 5 centimeter. So here you use 5 for measuring, na? Suppose there are 3 boxes are there. Inside 3 boxes you kept different types of pen. Here red pen, here blue pen, here pencil. Okay. How you remember in which box which things is available? Suppose you label 1, 2, 3. Okay. Then number. Before today you are using Indian based system. For writing the number we are using Indian based system. Like I am telling you 123. You are writing this number, na? It is Indian based system. Before this two system are there. One is tally marks. One is tally marks, and one Roman numbers. Roman number. Tally marks means, look, example 5. Suppose I am representing 5 by tally marks. 1, 2, 3, 4. Means in vertically we can able to draw four line, and in horizontally you can draw one line, like 6. So 1, 2, 3, 4, 5, then one vertical line. But think na, if I suppose I'm telling you write down 123 by tally mark, it's impossible. But it will take much time. Then Roman number, Roman number 1 I, 2 double I, 3 triple I, 9 IX, 10 X, then 50 L, 100 C, 500 D, 1000 M. But suppose I'm telling you write down 1,23,562. It will take lots of time to write this number. So that's why all the world going to learn Indian based system Indian based system of numbers. It's easy. Suppose I'm telling you 1,23,542. It's easy enough for writing. Okay. Then there is a one type of number called even number, called the even number.
Even number.
What do you mean by the even number?
2, 4, 6.
Mhm.
जो कि 2 के टेबल में आ गया.
Give one generalized formula, that is divisible by 2. Divisible by
2.
okay. What do you mean by divisible by 2? Divisible means remainder should be 0. Remainder should be 0.
0.
If I divide that number, the given number by 2, remainder should be 0. If remainder 0, then it is a even number, otherwise it is a if remainder 1, if remainder 0, even number, remainder 1, odd number. Okay? Look, 16. 16 is a even number. Look, 2 8 is 16. Remainder is how much? 0. 17 is a odd number. 2 8 is 16. Remainder is how much?
1.
Okay? And you remember, even number means divisible by 2, odd number means
Not divisible by 2.
not divisible by 2. Okay. Then the thing is, negative number maybe prime or even, prime or odd, even or odd, negative 2. Is it even or odd?
Even.
Remember, from even and odd we consider negative number. For prime or composite, don't consider negative number. Okay? This is the note point. That the note point is negative number. NN means negative number. Negative number may be even or odd. Even or odd. Same. Just divisible by 2, then it is. You only have to check the remainder. If remainder is 0, then even number. If remainder is 1, then odd number. Then tell me, then tell me 0 is even or odd?
Neither odd nor
even.
Are
divide by 2 na. Why are you thinking about these things? I'm telling you na. If remainder is 0, then even number. If remainder is 1, then odd number. Why are you thinking about this? 2 zeros are 0. 0. So it is a even number. Okay. Only remember the formula. Divisible by 2 means remainder is 0. The natural number denoted by n, starting from 1, end at infinity. What is the smallest natural number? 1. Largest I cannot say. Whole number, natural number including 0. Natural number including 0. 0 is the smallest whole number. Infinity is the, I cannot say, the greatest number. Then integer. Integer means 0. Positive counting number, positive
or negative
counting number, negative counting number. Or you can say whole number with negative. Then tell me, minus 1.7. Is it a positive or negative integer?
Negative integer.
1.7 I am telling you.
Negative बोला.
ये it is not a integer first. Okay, it is not a integer means it should be whole. It should be whole. Okay. Then can I conclude that small box natural
number. Negative rational number.
Natural, then whole means 1 to infinity. Natural. 0 to infinity. Whole. Minus infinity to plus infinity. It is integer. And remember, integer is denoted by z. Okay? Okay. Then come to prime number. Then come to, look, we are completed two types of number. One is even, one is odd. One thing you remember, negative number may be even or odd. Don't think only positive number. No, negative number also even or odd. And even means divisible by 2. Divisible by 2 means remainder equal to 0. Odd means not divisible by 2 means remainder equal to 1. Okay? Then come to prime number. Listen the definition of a prime number. Natural number. First it should be which type of number? Natural number. That means we don't consider 0 or minus things. Okay? Natural number greater than 1. Natural number greater than 1. Which is divisible by? Which is divisible by 1 and the number itself. 1 and the number itself. 1 and the number, that number itself. Okay. Natural number greater than 1 means 1 is neither prime nor composite. Which is divisible by 1 and the number itself. Or I can say it has two factor. It has two factors. One and the number itself. Factors mean on which table the number is coming. Okay. For example, 2. How many? 2 is divisible by 1 and the number itself. 5. 1 and 5. 7. 1 and 7. 4. 1. 2 or 4. So it has 3 numbers. So it does not divisible by 3 number. So it does not comes under prime number category. Okay.
Composite number. Okay.
Then composite number. Then composite number same. The natural number greater than 1. It should be natural number greater than 1. Divisible by 1. The number itself. The number itself and other number and other number and other number or numbers. Number or numbers. Okay. Natural number greater than 1 divisible by 1 and the number itself and other number or numbers. The other number means 4. 4 is divisible by 1, the number itself and other number. Na? Only one number is there, 2. But if you consider 12, 2, 1, 3, 4, 6, 12. Okay. And when can I say composite number has have more than 2 factors, more than 2 factors. Okay. Okay. Then come to rational number. Rational number means any number that can be represented by numerator upon denominator or p upon q. It is nothing but numerator upon denominator. Where q not equal to 0, pq must be integer. Pq must be integer. Okay. Then you know the example, na? All the natural number, all the whole number, all the integers, all the fractions are the example of a rational number. Only 2. How 2 is a rational number? I can write 2 is equal to 2 upon 1. Then apply all the 3 rules. Then irrational number. Irrational number. Any number that cannot be represented in the form of p upon q. Cannot be represented by p upon q, where q does not equal to 0. pq must be integer. Pq must be integer and whose decimal expansion are whose decimal expansion. Which type of decimal expansion it has? A irrational number has which type of decimal expansion? Irrational number decimal expansion को भलिया non-terminating, non-repeating. Are any number that cannot be represented by p upon q or means include the definition. Their decimal expansion is non-terminating, non-recurring. Non-terminating, non-repeating or recurring. Actually, look, try to understand the decimal expansion. Decimal expansion of any number. Decimal expansion are of 2 types. One is terminating or is one is another is non-terminating. Actually, this non-terminating also two types: non-terminating, recurring or repeating, non-terminating, non-recurring. Remember, these two are comes under rational part: terminating and non-terminating, recurring. Okay, but this concept is comes under means whose decimal expansion is non-terminating, non-repeating, non-repeating. Like pi. What is the value of pi? It is approximately 22 upon 7. Actual the value of a pi is 3.141592 dot dot dot. Means it is pi is a irrational number. Pi is a irrational number. Why? Because it is a decimal expansion is a non-terminating, non-repeating. Okay, and you know the value of root 2. What is the how much is the value of root 2? 1.414 dot dot. Root 3 1.732. Root 5 is 2 point something. Okay, all are non-terminating, non-repeating decimal expansion. Means I can easily, by one word I can say irrational number are the decimal having decimal expansion, non-terminating, non-recurring. Then the concept co-prime, because this co-prime concept is required for proving root 2 is a irrational number. What do you mean by co-prime? What do you mean by what do you mean by co-prime?
अरे ऐसे दो नंबर जो
First give me the answer. Co-prime, we find co-prime from prime number or any number?
क्या
We find co-prime from any number or from prime number?
prime number.
That is the first thing you have to remember. Suppose one person name is Kalia. That means 100% it should be black color. No, na. Same thing. Co-prime means any number, any pair of number, any pair of number. Remember, because many students think that co-prime means we are finding the number from prime number. No, the name is co-prime. Any pair of number whose HCF is 1, highest common factor is 1. Okay, pair of number means always you are trying to find co-prime from two number like 3 and 7. Okay, for finding co-prime you require two number. You require two number, and only checking HCF means highest common factor should be 1. I am giving you one example. Look, 4 and 9. Look, 4 is a composite number, 9 is a composite number. Don't think about composite number. Find the factor. 1, 2, 4, 3, 1, 3, 9. Look here. Common factor is 1. Na? Common factor is 1. Na? That means HCF is 1. Na? So can I say 4 and 9 are co-prime? Yes. Okay. You understand what I mean by co-prime? Only remember co-prime we find from any number, but the number should given in pair. Like look, 5 and 7. HCF is 1 or they having common factor only 1. 5 and 7. 5 and 7. ये co-prime है? Yeah, because I know the HCF of how to find HCF by long division method. 5 1 ja 5, subtract 2, then divide this the divisor by the remainder. 2 2 ja 4, 1, again divide by 2, 1 2 ja 2. The divisor which by which you get 0, this is the HCF. Okay.
HCF1 तो ये हो गया
Okay.
prime.
For checking large number, you have to apply this method, like 50, 30, 24 and 36. Or you don't have that much time to find the HCF, na? Then directly divide. 24, 24 ones are 24. Remaining is 12. Then again, until you get 0, you have to again divide. 24. 12 to ja 24. 0.
24.
Now you look, this is the divisor by which you got 0, na? Then that means 24 and 36. HCF is 12. If HCF is 12, that means they are not coprime. Then the next concept, 2 in prime. 2 in prime. It is one new type of number. 2 in prime. Here it should be prime number. Okay. Means first it should be given in pair and it should be prime. Okay. Means for finding 2 in prime, first thing it should be given in pair and it should be prime. Means difference should be 2. Difference should be if any prime number, if any 2 prime number and the difference is 2, then I can say they are 2 in prime. Okay. You understand? 2 prime number, if I subtract this 2 prime number, the difference should be 2. That means A is a prime number, B is a prime number. If I subtract B minus A, the answer should be 2 because B is greater, na? Look.
5 or 7, 3 or 5.
3 or 5. 41, 43, 17, 19. These are called 2 in prime. These are called 2 in prime. Let's move to the book. Real number, we completed all these things. The fundamental theorem. I want to explain these things. Fundamental theorem. Look. Fundamental theorem. Look, this is called the fundamental theorem of arithmetic. What is it called? Fundamental theorem of arithmetic. Okay. What does this theorem say? Every hello. Is my voice clear?
Hello.
Every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factor occurs. What does it mean? Simple meaning. Composite number equal to factor of product of a prime number. Product of a prime number. This is the main concept. You have to understand. Means any composite number. Cn means composite number. I can convert this composite number as product of a prime number. For example, 4 is a composite number, na? I can write it is a 2 into 2, 6, 2 into 3, 9, 3 into 3, 36, 2 into 3 into 3. This is called prime factorization. This is called prime factorization. So look, is unique. Unique means look 36 and 4. Both having same factorization? No, na. Both having different product, na. Order? Or you can write 3 into 3 into 2. Don't worry. Here it's apart from the order. Okay? You understand this theorem? This is called the fundamental theorem of arithmetic. Only one line you have to remember. Composite number equal to product of a prime number. Product of a prime number. If the number is such a large number, how to find? Because sometimes they gave you the question. I think in exercise 1.1 also this type of question is there. Okay. Find the prime factorization of a 128. Then remember prime. We apply one method called prime factorization. Prime factorization. What do you mean by prime factorization? Divide the number by prime number. If it is a composite number, if it is a look, we find prime factorization for a composite number. Okay, and we know we can convert this composite number as the product of a prime number. Then divide the number by prime number. Okay, I am doing one example 128. Now I have to convert this composite number as product of a prime number. Okay, so what should we do? Divide by prime number. Divide by prime number. First prime number is 2. 128 is 128 is 28 is divisible by 2. Yes, because the last digit is 8. Or not like this. You have to write like this. 128. 2. 2 6 ja 12. 2 4 ja 8. Again it is divisible by 2. 30. 2. 2. 16. 2. 8. 2. 4. 2. 2. 2. 1. So write down how many 2 are there. 1 2 3 4 5 6 7. I can write 2 7 times or 2 raised to the power 7. Okay, or you can find any number. 69 is it divisible by 2? First remember one thing. You remember, whenever you are doing prime factorization, first check the given number is a prime or composite. Okay, sometime they gave you the question 41 and telling you find the prime factorization. Or look, prime already 41 is a prime number na. We do prime factorization for composite number, not for a prime number. So look, 69, yes, it is a composite number. How you know? Because 13 3 is a 69. Okay, 2 table. Is it divisible by 2? No, because the last digit is 9. Is it divisible by 16 3? How you know?
9 plus 6 15
9 plus 6 equal to 15. Yeah, correct. 3 3 2 ja 3 3 ja. Is 23 divisible by any number? Because 23 is a prime number. So 3 into 23. Okay. Okay. So today we completed some basic concept with the theorem whose name is a fundamental theorem of arithmetic. Okay. Tomorrow I will complete exercise 1.1, exercise 1.2, 2 exercise. Okay. Only practice this. Only practice this much. Okay. That's enough. You remove from the class.